The tunnel you are seeing is not an ordinary tunnel, it is in fact the world's largest tunnel that literally passes under the sea. This 50-kilometer long tunnel is that mega project which engineers call the seventh wonder of the world. The main reason for this is its construction. Working with 13,000 workers altogether in extremely challenging conditions and to excavate a part of the ground upon which the weight of the whole sea is bearing down. One small mistake can fill this tunnel with water and can bury both humans and machine forever, and that too in just a few seconds. Viewers, about 13,000 years ago, when the last ice age was coming to an end, so it separated today's England and Europe from each other. The reason for their separation was this part of the sea which is now called the English Channel. Although this channel is quite wide, but it becomes quite narrow at this point. And at this point, England and France are only about 33 kilometers apart from each other. Many times in history, attempts have been made to bridge this gap, but these experiments were stopped after many lives were lost, because perhaps the technology was very limited at that time. But by the end of the 20th century, when technology was advancing rapidly, then once again it was thought of connecting England and France by land connection. It was the era of 1980th century when it was possible to build larger machinery. Apart from the machine, there was another challenge, and that was to convince England. Yes, the cold waters of the English Channel have always given England a heavy hand over its enemies. From Napoleon to Hitler, many enemies of England planned to capture it, but it was the harsh condition of the English Channel that always gave England that upper hand. In World War II, Hitler from a village called Calais in France launched a secret project to dig an underwater tunnel so that they could gain control over England. However, this project could never be initiated. Well, after Hitler's death and World War II, significant change began to occur in Europe. Business started becoming and prosperity was everywhere. France and England, who were once enemies, started trading through the English Channel. As time passed, in 1986, both countries decided that now they would remove this barrier and connect England with Europe. There were many protests in England against this decision, because many people took great pride in England's island sovereignty. After several months of long talks, both countries finally agreed to build an undersea tunnel. It was named the Channel Tunnel, which is often referred to as the Eurotunnel by many people. It was agreed that teams from England and France would dig the tunnel from their respective sides, and both tunnel segments will connect at the center points. The project looked like a colossal failure even before it started. Constructing a tunnel approximately 38 kilometers long beneath the sea, it was not a task that any engineer's firm would dare to undertake. Eventually, it was decided that 10 engineering firms would collaborate with each other to construct the project. Before finalizing the design of the Channel Tunnel, it was essential to know that which type of transport would run through the tunnel, and where the tunnel would start and where it would end. It was decided through mutual understanding that a total of this tunnel will be built, in which a railway loop will run between England and France. One terminal will be in the French city of Calais, while the other terminal will be at Folkestone in England. The total length of the tunnel will be 56 kilometers, but of which the underwater part will be 38 kilometers long. Finally, in 1986, the construction of the Channel Tunnel was started. The biggest challenge the engineering team had to face was the tunnel boring machine, also known as TBM, because before this there was no project like this ever built. That's why a TBM of this particular diameter was also not available. First, this TBM machine will have to be built from scratch. Thousands of miles away in Seattle, Washington, the Robbins Company was commissioned to build this particular tunnel machine, who are experts in making boring machine. Once completed, this gigantic machine will be 800 feet long and weigh 1500 tons. Its diameter will be 15 feet with multiple sharp edge blades made of tungsten carbide at its front. The hydraulic legs attached to it will push it forward. A conveyor belt will be installed inside the machine to remove soil and cruise stone to the outside, which will carry the debris to the service stand, and then this train will take the debris out of the tunnel. This tunnel boring machine was a marvel in itself. The old technique where mountains were blessed to build tunnels. In comparison to that, this machine was a significant blessing for developers. But this technology also brought along many risks and challenges. If water leaked from somewhere during the 250-foot depth underwater boring, so its pressure will be so high that it would drown both man and machine in a matter of seconds. The survey revealed that there is a layer of chalk beneath the seabed on the England side, which will prevent water from leaking into the tunnel. But on the France side, there are many cracks in the seabed where this TBM won't work properly. For this, a decision was made to build a new TBM separately, which along with tunnel boring will also be a submarine. It will be able to withstand as much water pressure as World War II submarines when this machine was developed. It brought a new challenge with it: how to deliver it 200 feet below the ground. The machine was disassembled for this task, and each piece was separated take down below. It had to be reassembled after going inside the ground. It took several months and millions of dollars in expense. 2 years had passed since the project started. Construction work on both sides was finally initiated in 1988. Disposing of such a large quantity of soil and rock debris was a momentous in itself. The machine was cutting 750 square feet of stone in a single day, and in just 1 hour about 2400 tons of debris was accumulating. On the England side, the wreck was built into a country park called Sampire, who under the Shakespeare was clipped between Folkestone and Dover, and that's why it slightly protrudes from the coastal line. The debris collected from the French side was in the form of mud. An artificial lake was created by pouring it into the Fond Pignon Valley near Sandgate. On the one hand, so much debris was being taken out of the tunnel. On the other hand, there was also a lot of material being taken in. As the TBM, that means tunnel boring machine, progressed at the same speed, sealing the lost rock and clark layers was also crucial, because if the seawater above made way for the tunnel, that it would become impossible to stop it For this work, round concrete slab of the size of the tunnel were being fitted. This concrete is even stronger than the concrete used in nuclear plants. About 7,50,000 concrete slabs were used in the reinforced steel channel tunnel. The weight of one full-size concrete slab is equivalent to 40 tons. That is, this total is as much concrete as 8 key buildings like Burj Khalifa can be built. The wire put in the service train and taken to the tunnel, where there was a special machine that was fitting them in place. Several weeks passed and then months. The tunnel was slowly progressing forward from both sides. Everyone was eagerly waiting for the moment when these two tunnels would meet each other, although it may seem simple to us and hear about. In reality, it was quite complicated. If the two TBMs are not advanced in the right position, it is obvious that the two tunnels will never meet each other under the sea. For solving this issue, the laser beam guidance system was being used. One laser was installed in the English machine and the other in the French machine. Both guidance systems were wirelessly connected to each other. Whenever one of the machines changed its position, the guidance system sent a signal to the main computer to change the position of the head of the boring machine with a hydraulic jack. As a result, both tunnels realized with each other again. Whether this guidance system was working properly or not to confirm this, both the machine will be shut down in the last 100 meters and then a steel route will be sent to the next site to confirm that the position of both tunnel is accurate or not. After 3 years of continuous boring, finally the moment had arrived when only a distance of 100 meters remained in between, and according to the plan a steel route was sent through. The position of both tunnels were almost accurate with only a 10-inch difference, which aligns within an allowed limit. Now the engineers team faced their biggest and last challenge. It was very important to make one of the two TBMs commit suicide. Yes, because 2-foot thick concrete slabs had been installed in both tunnels. That means the tunnel diameter had reduced from 50 feet to 46 feet, and the diameter of the TBM's boring machine was 50 feet. After the completion of work, a 50-foot machine cannot come back out of a 46-foot tunnel. Therefore, the solution to this problem was derived that one of the machines will have to be removed from the path, what engineers call mechanical suicide. So, this sacrifice was made of England's TBM. It was titled by changing its angle towards the ground. After descending several hundred feet, it was left there, where it is buried till today. Now the final moment of the construction was near the French TBM went ahead and finally met with the English tunnel. And upon reaching there, the French TBM was dismantled and taken out. And upon reaching there, the French TBM was dismantled and taken out. Now you might be thinking that English TBM could have been disassembled, so why was it buried then? In reality, it was costing as much to disassemble the boring machine with lower cost. A new machine could be made instead. That's why the company first assesses which option will incur less loss. Based on this decision is made whether to bury it forever or to take it out again. The first time in 13,000 years, a land connection was about to form again between the two countries. As many workers were working for this event, one worker from each country was selected to broke that last layer of chalk manually with jackhammer, and for the media event, they exchanged flags with each other. thousands of years ago after being separated due to glacial air. Finally, England to France had reconnected once again. It was indeed a significant achievement, and to celebrate it, a grand celebration was held.